All right, normal distributions, example 3, part B. We've already talked about the purchase prices of these Mercedes-Benz convertibles. So this question, we've got the bell curve. We were told it's normally distributed. That's important. We put the mean in the middle. All right, a good price, according to TrueCar.com, would be between 100,047, and which is below the mean, and 102,429, which is above the mean. And according to TrueCar.com, if you purchased one of those between those two prices, you got what they call a good price. All right, we're supposed to find the percentage, that's the shaded area under that curve. So the percentage of cars, now the variable again is X, right? Because this is a generic variable, it's not standard. And the way you would write this up as a probability statement would be 100,047 less than X, which in turn is less than 102,429. That's how you mathematically write between. All right, so there you go with that. Now again, the problem here is that this table does not speak the language of X, right? It's got to be Z. So we've got to convert this into a standard normal. What I like to do is draw the bell curve with 0 in the middle. And again, we've got one price that's below the mean. We've got another price that's above the mean. And we're looking for the percentage, the probability, the area between them. This is going to hopefully translate to a negative Z-score. This will be a positive Z-score. But we're going to standardize it. And there again, we changed the variable from X to Z, and we standardize both of these prices. We convert them, we translate them. And again, see, the table only speaks the language of Z, so we've got to translate those X's, those prices, into Z-scores. So, same thing, this one, the Z-score would be that price, 100,047, minus the mean, the 101,879, divided by the standard deviation of 1,430. And that'll be the Z-score for that particular price. So again, and I should have done this ahead of time, but oh well, didn't think to do it. A lot going on here. But it looks like, now after you subtract this, make sure you hit equals, and then divide that answer by 1430. Let me see, I got excited and I hit too many buttons. Let me start over here. It's hard to talk and stand and punch buttons. I got negative 1.28. Remember, this table forces us to put these out to 2 decimal places. So there is a protocol here, 2 decimal places. Yeah, you know what? That's negative. That's good. It's below the mean. It's 1.28. That price is 1.28 standard deviations below the mean. That's the interpretation of that. All right. This price, which is above the mean, same thing. 102,429 X minus mu 101,879 all over 1,430 X minus mu over sigma 102,429 minus 101,879 equals, divided by 1,430. I'm looking at my math one more time just to make sure. I think so. That turns out to be positive 0.38. All right? And that would be that Z-score. Yay! Guess what? Now we can go to our friend at the table and say, hey, table, I get it. You don't speak X, you speak Z, and it's ready to roll. So let's look up these 2 Z-scores. This now becomes the kind of question that we enjoyed on example number 1. And when we look up 1.28, it'll give us that middle sliver, won't it? So 1.28, 1.28, 0.3997, and that would be this area here. This is where we use the logic that we did on example number 1, once it's been standardized. We look up 0.38, the other Z-score over here, and that creates an area of 0.38. I hope I'm reading this right. 1480. And as per the logic that we did on assignment number 1. That's combining two middle slivers. Add those two numbers. So I'll do that over here. 0.3997 plus 0.1480. Making sure, right? That's 7. That was 17, 14. 0.5477, I hope. Embarrassing if I'm wrong. Let's change it to a percentage because the question did specifically ask what percentage of cars are purchased for a good price. There you go. It's about 54.77%. So there's that. Let's go ahead and look at another one here soon.